Hello, and welcome to this podcast mini-series on coastal resilience in the face of climate change. I'm Josephine Anselin. I'm a PhD student at the University of Cambridge, and I'm currently doing a policy internship at the Centre for Science and Policy here in Cambridge. Through this podcast series, I'm hoping to shed some light on coastal resilience, a topic that has been close to my heart ever since witnessing coastal management issues firsthand while living in Jakarta, Indonesia's capital city, which has also been referred to as the world's fastest sinking city. In each episode of the podcast, I'll be talking to a different coastal research expert. And together, we'll explore a specific aspect of the UK's coastal adaptation to climate change. We'll discuss some of the latest science, the links between academic research and policy, as well as steps that academics can take to help bridge the gap between coastal science and policy action. Today, I'm delighted to be joined by Professor Tom Spencer to discuss nature-based solutions to enhance coastal resilience. Professor Spencer is Emeritus Professor of Coastal Dynamics and the Director of the Coastal Research Unit at the University of Cambridge. He has worked with communities and institutions in coral reef and mangrove forest environments in the Caribbean, the South Pacific, Southeast Asia, and the Western Indian Ocean, and also on salt marshes and mudflats bordering the North and Baltic Seas. So without further ado, let's get into this conversation. So first of all, thank you so much for taking the time out of your schedule to have this conversation and to share your expertise. So I'd like to start by asking you, what personally drew you to studying coasts and coastal dynamics?
Okay. Well, I was born within sight of the sea in Plymouth in Devon. That's a very rocky coast. And then when I was probably about 10 years old, the family moved to outside London. And so I started visiting the sort of Thames estuary, so very kind of low-lying coast. So I guess I've been, it goes a long way back. And then when I started as an undergraduate student at Cambridge, we go to there'd be field trips to the North Norfolk and the Suffolk coast. So I've always had that kind of coastal interest. And I think why I got into research on coasts is coasts are interesting because they're affected by very high energy, but they are composed of very erodible or very movable sediments. So you can see things happening. And I'm very interested in sort of environmental processes, and the coast is a great place to study environmental processes. So, if you have a storm, you see erosion, you see sediment being moved around. So they're very dynamic. And I think I've always been attracted by studying a system that is dynamic, and also, of course, they're very important. They're important both in a kind of economic sense, but they're also important, I think, in a kind of human sense, because people like to go to the coast. They like to be in coastal environments. So I'm a geographer. I've always seen myself as a geographer. I'm very interested in the interactions between physical and biological processes and sort of cultural and social processes. So the coast is an area where those things come together. So I think for a whole series of reasons, I've always been very interested in coasts.
Yeah, thank you for sharing that. And yeah, it's very interesting that you traced it all the way back to your childhood. And at that time, you probably weren't aware of all these systems. But yeah, thank you for sharing it. So before we talk about actual solutions that exist to enhance coastal resilience, could you please give a brief overview of the main impacts of climate change on coastal zones, and particularly applied to the UK?
Yeah, okay. So the British Isles is a very small island, and it sits on the edge of a very big ocean. And so it's clearly very heavily affected by what's happening in the ocean and what's happening in the shelf sea of the North Sea around it. Of course, we tend to think about sea level rise and accelerated sea level rise as probably going to be very important for the future of the UK coastline. But I also think we've become much more interested in the last few years about the role of extreme events So perhaps, 10 years ago, we would probably have talked about climate change in terms of changes in global temperature, it changes in global sea level. And I think now we've started to get more interested in the possible changing characteristics of storms, perhaps increased frequency of storms, perhaps increased magnitude of storms. And, people are starting to say, well, perhaps the climate signal and the climate change signal is actually going to show through in the change in extremes. And of course, on the west coast of the UK, we're very exposed to storms that come in from the Atlantic. And on the east coast, on the North Sea coasts, we have this hazard of storm surges, periodic storm surges, which come down the North Sea. So I think those are the kinds of things which we need to think about. Having said that, I think it's quite difficult to disentangle the climate change signal from the general dynamics of these systems. And we've got a lot of very modified coasts where human interventions have changed the movement of sediments, they've changed the focusing of waves on those coasts. So actually trying to see the climate signal is quite difficult, I think. But I suspect that's something that's going to become more apparent as we go into the next few decades.
Yeah. Yeah. And when it comes to these extreme events that you mentioned and like storm surges, like the first kind of impact that comes to my mind is flooding, but do storm surges cause any other damage or any other effects?
Well, you're right. I think storm surges are generally associated with flooding, because where you have low-lying coasts, and if you have defences which fail, then it's very easy to get quite high impacts on infrastructure, on roads, railways, and so forth. We also get on sandy coasts, we also get erosion. When we look at salt marshes, it's interesting because although you would think that marshes would be very badly affected by surges, that actually the evidence suggests that they're actually quite robust when it comes to storm surge impacts. Yes, they get flooded quite deeply with floodwater. There is some erosion, but it tends to be on the edge. So they do seem to be more robust than you might think.
Okay, yeah, and we'll definitely get onto salt marshes
in
more detail later on. But yeah, first I just had another question for you with regards to the way in which we've approached kind of coastal management. So in recent years, there's been a shift from using engineered structures, like for example, seawalls, towards more nature-based solutions to manage the coastal hazards that you just described. So could you explain what some of the issues are with engineered solutions and why they may not be sustainable in the context of climate change?
So the traditional approach to coastal defence has been to build some kind of structure. And of course, the great advantage of that is that you have very well known design rules for seawalls and other structures. So you can say, okay, we'll have a defence of this particular height to survive this particular, let's say, the 1,000-year storm. You know what the maintenance costs are going to be. So it's a relatively straightforward process. The problem with engineered structures is that they're static and they're fixed in position. And so they can only ever be a temporary solution, because there's going to come a point when they're not high enough, they're too far seaward, they're going to be they're going to be under pressure and they're going to start to fail. So that's a really big problem. And the difficulty is you can't just put a little bit of extra height on an engineered structure, because that engineered structure is really a kind of three-dimensional form. It has to have proper footings, because otherwise it will fail. So it starts to become very, very expensive. And this is the difficulty, that you continually you're locked into then a kind of reactive system where you are over time replacing your structure, and it's going to be bigger, larger, higher every time you replace it. So you get locked into that kind of management regime. So
Okay.
that's the difficulty with a engineered structure. It's static, it's fixed in position. So the advantage of a nature-based approach is that you've got something that is dynamic and should be able to shift with climate change, with environmental change. So, for example, if you have a salt marsh is accrete, so they have the potential to track rising sea levels. So potentially you have a system there which is much more sustainable in the long run. The difficulty is you have to provide those sorts of systems with space to do this process. So if you have sea level rise and if you have some kind of wetland, then in theory, it should be able to track that sea level. And it does that both vertically by growing upwards, but it also does it laterally. It shifts to a more landward position. So if you have a seaward slope, it's shifting up that slope, if you like, to adjust to sea level. The difficulty, of course, is you need to have sufficient sediment supply to maintain that growth process. And that might be difficult if you've dammed your rivers and you've stopped fluvial sediments getting into the coast. If you've built defences in front of soft rock cliffs, which might be supplying the sediments and therefore prevent the sediments being eroded from those cliffs and put into your wetlands. So you might have a problem with sediment supply. And the other problem is you might have some kind of defence, and this is very common, behind your wetland. You might have some kind of seawall or sea defence, perhaps an earthen bank or something like that, and that prevents the salt marsh, the wetland, from migrating in a landward direction. So you have a situation where you've got perhaps increased energy inputs at the seaward margin of your wetland. If you've got sea level rise, you've got greater water depths, you're likely to have higher waves, you're likely to have more erosion at the seaward margin of your wetland. And the wetland can't then simply translate landwards because you've put some kind of fixed defence line behind it. So this problem is called coastal squeeze. So what happens in that case is gradually your wetland gets narrower and narrower in front of your defence. It might still get higher because there might still be plenty of sediment around, but it'll get narrower and narrower. And eventually, of course, there comes a point where it's removed completely, and then the waves are starting to hit your defence line. So that's really one of the challenges for these nature-based solutions. How do you look after those wetlands? One approach to this is a process known as managed realignment. So you allow your defence to be breached, or you either artificially breach it, or you allow your defence to degrade and then naturally breach, and then you create an area of wetland behind the old defence line. You probably set up a new defence line, but at a more landward position. And around a lot of the UK coastline, we have a lot of reclaimed salt marsh, which has then got seawall in front of it. So there are these spaces which could be reflooded by renewed tidal exchange. That in itself is quite complex because if you've isolated those areas from tidal exchange for a period of time to convert those areas to agriculture, so you might have a seawall that's been there for 100 or several hundred years. That's 100 years or several hundred years when no new sediment has been added to that area behind the seawall. So that hasn't been tracking sea level. And you might also have had agricultural machinery on those sediments, which would then have compacted them, perhaps even changed their physical and chemical characteristics, so that when you reflood those areas, it's sometimes quite difficult to sort of turn the wetland tap back on. You're flooding an area which is probably much lower and might well have surface characteristics which are not so conducive to the re-establishment of vegetation growth. So these managed realignment schemes are challenging because you have to then provide the conditions to trigger that marsh development process again. But there are solutions in there either maintaining and looking after your existing marshes, that they're doing their job, or sort of recreating marshes where marshes were in the past, to then try and get them to react to sea level rise.
Yeah, that's very interesting. And it does kind of emphasize what you said at the beginning about having to consider the whole system. So yeah.
Yes, so it's a huge management challenge.
Yeah. And you mentioned salt marshes and wetlands. Are there other, sometimes we hear about like coral reefs, but I don't know if those exist in the UK, but are there other kind of nature-based?
Yes, I mean, if we were talking about nature-based solutions more widely, we could be in tropical environments, we could be talking about mangrove forests and restoring, maintaining, replanting mangrove. We could be talking about what could we be doing to preserve and encourage coral reef growth. And we could also think about seagrasses in lagoons. We've got seagrasses around the UK coast as well, and there's a lot of interest at the moment in trying to improve and repair seagrass beds. I mean, these tend to be below the sort of lowest spring tide, so they're not easily seen in the way that, say, an intertidal salt marsh would be seen in the UK, but they're very important. They clearly stabilize sediments. They probably do have some energy reduction role as well. So we could also talk in a UK context about seagrass and the preservation and restoration and improvement of seagrass meadows.
Mm-hmm. Yeah, and so you mentioned here the kind of energy reduction. So is that how seagrass or salt marshes, how they reduce flood risk, or like, yeah, what are the processes there?
I think marshes provide two benefits. They reduce wave energy, and we know that by direct physical measurements. We know that they can reduce incoming energy levels if you have tides which just flood a surface. So you've got quite shallow water depths. That energy reduction, say 200 meters from the edge of the marsh to some kind of defense line, might be 90%. So they're very, very effective at reducing incoming wave energy. What they also do, you can think in a sort of estuarine context, they also help with floodwater storage. So if you've got a storm surge coming in and clearly there's a peak water level associated with that, if you can store some of that surge water over a wetland surface, then that's going to reduce the flood peak further up the estuary, perhaps in those areas where your flood defences are threatened around towns or infrastructure. So I think both those processes are very important.
Yeah, yeah.
I think what we also need to think about when we talk about nature-based solutions, and part of the whole philosophy of this is that you're getting a number of benefits. So you might well get a flood reduction, flood risk reduction benefit, but you would also, by encouraging healthy salt marsh, healthy seagrass, you might also get biodiversity benefits. And I think, of course, marshes sequester carbon. So there's also a climate mitigation benefit, which you clearly don't get from a concrete seawall. And then I think there are some human benefits as well. People like to, walk along structures, seawalls, and see flowering salt marsh. So, there are, and there is some literature on this, that salt marshes and wetlands are good for human well-being.
Yeah.
And it's quite interesting that, if we've been talking about this probably 40 years ago, salt marshes were seen as being of very little value. They were often described, and rather like mangroves. We now tend to talk about mangrove forest. We don't talk about mangrove swamps. So wetlands were often seen as, in a very kind of Dickensian sense, as being really rather unpleasant, rather valueless environments, and of course many of them were used for dumping industrial waste and things like this. So they were seen as being of little value, of little importance. And I think our whole kind of view of the value of wetlands has changed enormously, and we now see them as these really important biodiverse functional systems which are doing a lot of good. And that was certainly not the case 30, 40, 50 years ago.
Yeah, very interesting. And another question I wanted to ask you, you sort of touched on it already, but would you say that nature-based solutions like salt marshes can completely replace these engineered protection measures like seawalls, or is it sometimes actually better to use both in combination?
Yes, I think that's a really important question. We have to be very careful that we don't see these sorts of solutions as a sort of silver bullet. One of the difficulties is we still don't have really good design rules for the use of these kinds of systems. It's really an area where lots of people are interested, lots of organizations are interested in nature-based solutions. They think they can see that this is a good thing to do, but the implementation and the proper implementation is really quite difficult. So I think there are several examples here of where policy has been running ahead of science. We might come on to that question in a minute. So it's quite difficult, and you're right. I mean, I don't think you're not going to protect London and the Thames estuary with nature-based solutions. I mean, you're almost certainly in that instance going to have some kind of second-generation Thames barrier, because there are clearly locations and instances where you're going to have to use hard engineering. But you're quite right. It would be, there are clearly locations where you might want to think about moving to a fully nature-based kind of solution. And indeed, this idea of what we might call hybrid solutions, where you have some kind of defense, but perhaps in front of it, you have a created or a restored salt marsh, or you've done something to look after your mudflats and your seagrasses on your mudflats. That, I think, makes a lot of sense.
And at the beginning of the conversation, you sort of mentioned that one of the advantages of, for example, a seawall is that we have very clearly defined design parameters. But now when it comes to a salt marsh, how would you actually assess how effective this salt marsh could be in terms of coastal protection? And yeah, how do you, I don't know if you model a salt marsh, but yeah, I don't know if you could talk a bit about that.
So what we've done when we've been looking at individual locations and trying to assess the role of the salt marsh, what we tend to do is we use height. So we look at the and we look at wave action. So we measure waves both at the edge of the marsh and then at the inner part of the marsh, and we use sort of the height of the water as a kind of surrogate for how well that marsh is dissipating wave energy. And then we can relate it to things like the height of the surface, the width of the marsh. We might even relate it to the vegetation cover, the height of the vegetation, the types of vegetation present, how flexible that vegetation might be. So those would be the kinds of assessments that we'd make. And of course, what we'd really like to do over time is establish a kind of toolkit so that you could, for a manager, could go to any particular marsh and could make a kind of assessment as to the likely performance of that particular system on the basis of some fairly simple kind of measurements. Or indeed use that to identify, well, this looks like a system that's under stress where there are clearly problems and we need to do something about it.
Yeah, that would be, it seems like a great way to try and bridge that gap between the research, the science, and the actual implementation.
Yes. Because what we've found is that actually if you want to physically monitor wave action over a particular marsh, that's quite a long time process. You need to have recording equipment out there for quite long periods of time because you're just trying to capture some of the key events, and that doesn't happen, all the time. So it's not possible, for example, to go out over a single tidal cycle. So there's a monthly tidal cycle of spring tides and neap tides, and sometimes people feel that you can just go out and take some measurements over one of those tidal cycles. It doesn't really work like that. You need to kind of capture the extreme events. You need to capture those periods of time when you've perhaps got storms or surges, and you've got the more extreme events, because then that really tells you about how your system is performing. That's what you really want to know. You don't want to know what it's doing on a day-to-day basis. You want to know what it's doing when the big event comes in.
Yeah. Okay, and what's the current state of salt marshes around the UK? Like, are they conserved or are they slowly disappearing?
Yeah, well, we've had some areas and some periods when we've had very high rates of salt marsh loss, and it's obviously many people come to the immediate conclusion, oh, it's the result of sea level rise. Well, there probably is a sea level rise and a sea level signal in there, but it's actually quite difficult to pick that out. And there have clearly been phases of salt marsh loss in the Essex estuaries, for example, and then periods where there hasn't been loss. So you'd think if it was just a response to sea level, that the losses would be progressive and they might even be accelerating over time. And that's not always the case. So there must be some other things involved. Now, it might be to do with weather systems. So, do you get more salt marsh loss when you have a decade of more storms, or you have a decade perhaps in the North Sea of more easterly winds? Is it the result of the dredging of estuarine channels and therefore the increasing water depths? So it's not simple.
And you've already touched a bit on kind of challenges with regards to implementation. But like, from a policy point of view, do you think there are any other challenges when it comes to implementing nature-based coastal protection schemes?
Yeah, I think there are a lot of challenges. I mean, I know communities which are very interested in nature-based solutions, but they ask you some quite challenging and difficult questions. So they ask, is this going to survive a big storm? What's the maintenance cost going to be? And these are not easy questions to answer. We don't have decades of experience of these interventions in the way that we do for hard engineered structures. And so very often, I think communities are interested in nature-based solutions, but they're also a bit nervous that they're not going to work. And so, I mean, I could give you examples where communities have said, well, we really like what you're telling us, and we really like that possibility, but I think this time we'll stick with the engineered structure, please. And perhaps in the future we'll think about a more nature-based approach. So, that is quite difficult. And I think also there's a question of time. So communities, managers like to see sort of instant results. And of course, engineered structures give you a pretty instant result. I mean, once it's up and it's working and you've got that defense. It may take some time for a salt marsh, a wetland to develop if you create an area where you're hoping that vegetation will become established and you'll move into a sort of mature salt marsh. But that might take time, and therefore there's sometimes a little impatience that, well, it doesn't seem to be doing anything. Why did we agree to this? But it might just be a time issue, and that's quite difficult to sell as well.
Yeah, and so just following up on that, do you think there's some key science questions that would help to kind of alleviate these doubts?
Yeah. Yes, I do. I mean, I think what we should, as scientists, what we should be thinking about is what we want to do here is we want to work with nature. We want to set a system on a trajectory that will take us to the point where we have restored, recovered a salt marsh, which is then providing all these kind of flood storage and energy dissipation processes that we want it to do. So I think my view would be, well, let's think very carefully about how do we set a system on a path to get us to that endpoint? What are the things that we need to do? What are the sort of scientific nudges that we need to give to the system to help it on its way? And I don't think we quite have that at the moment. Mm-hmm. And I think the other difficulty is with nature-based solutions that they're attractive because they potentially they potentially deliver multiple benefits. So you'd like to think that if you do this, not only are you getting your sort of flood protection, but you're also improving your biodiversity, or you're doing good things for communities and society in general. But of course, if you're trying to deliver multiple benefits, you may have issues about trade-offs between those different benefits. So, which of these benefits are we trying to maximize? And if we do one thing, does it impact another? So that's another big challenge where you've got potentially multiple benefits. You've also got potential multiple tensions and challenges as you try and trade off between different benefits.
Mm-hmm. And finally, I just wanted to ask you what the biggest takeaway is that you hope listeners take from these conversations.
Okay, so I think the biggest takeaway is what's great about the nature-based solutions kind of set of ideas is that nature gives us coastal protection for free. We're not paying for it. The natural processes are delivering these benefits to us, to people. So the key thing has to be to work with nature. Nature's there to help. We need to work with nature. And the final thing I would say is these are, as we've already discussed, these are quite challenging ideas. They're not simple, straightforward interventions. So it's really, really important that if we go down this kind of route, that we go down it with local populations, with local groups, with local industries, so that you take people along with you. So there's a communication issue here about talking to individuals, to companies, to organizations as to why you're doing these things, why it's a good thing to do, and you want a sort of co-production of knowledge. So if you're going to make some kind of intervention, if you're going to try and create some salt marsh or recreate some salt marsh, for example, you need to take that local and probably regional communities with you. So there are some very important kind of governance and communication issues here. You will fail if you simply turn up and say, right, this is what we're going to do, and then perhaps have a consultation, but it's not really a consult. The kind of thing. I mean, it's not really a consultation. It's very important that you have that kind of buy-in and co-production of what you're doing.
Brilliant. Well, thank you so much for taking the time to take part in this podcast series. It's been fascinating to talk to you, and I've certainly learned a lot. I hope you enjoyed this discussion as much as I did. To hear more conversations like this, you can subscribe to the CSaP YouTube channel. You can also subscribe to the CSaP newsletter to get updates on a range of topics at the interface of science and policy. All the relevant links will be in the description of this YouTube video.